Hello, welcome to Unit 7, Lesson 5 with Professor Blackman. In this lesson, we're going to be talking about the graphs of quadratic functions. We're going to figure out how to get the vertex using the vertex formula. We're going to find the axis symmetry given the vertex, and then we're going to use that vertex to find the minimum or maximum value. After all of that, we're going to put it on a graph and look at it on the graph. Let's go ahead and get started with some examples. All right, so we have the vertex formula here. So when your quadratic is an ax squared plus bx plus c form, we could identify a as 1, b as -8, and c as 12. And then to find our x value, we do -b divided by 2a. So that's the opposite of b. So -8 would become 8 over 2 times 1. So that's 8 over 2 for our x value, which gives us 4. So that's telling us that our vertex that we are looking for, which is an ordered pair, is something 8. All right, and then from there we can then find it as y is the f of -b divided by 2a. So what we do to find y is we just plug that value in, and so that's 8 squared minus 8 times 8 plus 12. So that's 64 minus 64 plus 12, which gives us 12. So our vertex is at 8, 12. So my graph doesn't really go up to that, but we can do it roughly 6, 7, 8, and then 12 would be, somewhere like right there. All right, and then we need to find the vertex, the axis of symmetry, and the minimum or maximum value. Well, if you notice, our a value is positive, so it will be a minimum, because our parabola will look something like that. The axis of symmetry is the vertical line that cuts through the vertex. So vertical lines are always x equals. So our axis of symmetry is just going to be x equals 8. And then our minimum value, because our a is positive, will be that y value that we get there. So our minimum value is when y equals 12. And both of those are coming from the vertex. And that is what our graph looks like. Okay, let's look at the next one. We're going to identify a as 1, b as 4, and c as 5. So x equals -b over 2a. So x equals -4 over 2 times 1. So x is -4 over 2. So x has a -2 value. So for here, our vertex is at -2 something. And so now we find y by doing f of -2. So that is y equals -2 squared plus 4 times -2 plus 5. So that's y equals 4 minus 8 plus 5. So that is y equals -4 plus 5 is 1. So we have a vertex at -2, 1. And that's where our vertex is. All right. And so when we go to graph that, it looks something like this. And we have our graph of our parabola looking something roughly like that. So you can see that a is 1, so we have a minimum, because that is the vertex is the lowest point on the graph. And so we can quickly identify the axis of symmetry as x equals the value of the vertex, which is -2, and then we have a min when y equals 1. All right, let's look at some more examples. Okay, so here we need to find our value of our vertex using negative b over 2a and y as f of negative b divided by 2a. Okay, so let's identify our a as 1/2, our b as 4, and our c as 6. And really, we don't use c at all. It does help us find, our y-intercept. So we do know it will be going through there at 0, 6. So let's plug in, and we get x equals negative 4 divided by 2 times 1/2. So that is negative 4 divided by 1, which simplifies to just negative 4. So then our vertex is at negative 4 something. To find that y value, we plug in negative 4. And so we get 1/2 of negative 4 squared plus 4 times negative 4 plus 6. So 1/2 of 16 minus 16 plus 6, that would be 8 minus 10, and that would give us negative 2. So we can put that on our graph at negative 4, negative 2. All right, and so now we can find our axis of symmetry, which is x equals the x value in the vertex, and then our minimum value. And again, our a is positive, so our minimum, it is a minimum at the y value when it equals negative 2. All right, and then we can put that on our graph, and our vertex starts there, and our parabola looks something like that. Should be a little more curvy, not so V-shaped. All right, but as a rough sketch, you should be able to find those points. All right, and again, like I said, if we know our value of this 8 gives us our y-intercept at 8. So plug in negative b divided by 2a, and we can see that a is 2 and b is 6. So that's x equals negative 6 divided by 2 times 2. So that x is negative 6 divided by 4. So x is negative 3 over 2. So our vertex is found at negative 3 over 2 as our x value. And now we need to find our y value. So our y is found at f of negative 3 over 2, which as a decimal approximation is negative 1.5. That will help us when we graph. So then we get y equals 2 times negative 3 divided by 2 squared plus 6 times negative 3 divided by 2 plus 8. So that is 2 times 9/4 plus 6 times negative 3 would be negative 18 over 2 plus 8. So that's y equals 18 over 4 minus 36 over 4 plus 8 times 4 is 32 over 4. So now we all have a common denominator. We can simplify that 18 minus 36 plus 32, which would give you 14 over 4 or 7 over 2, which as a decimal approximation is 3.5. So we have our vertex at 3 over 2, 7 over 2. So graphing that would be negative 1.5, 3.5 right there, And so we know it's going to go through that point, and with symmetry, going to go looking something roughly like that. All right, and again, you can always build a table if you want to see the exact values. And now that we have both values of our vertex, we can say the axis of symmetry is x equals -3/2, and we have a minimum at y equaling 7/2. All right, let's look at some more examples. All right, so here we have it where our first a value is negative. So then we know that we will have a maximum when our a value is negative. We have a b of -6. And remember, our vertex is found by doing -b divided by 2a, and y is found by taking that -b/2a and plugging it back into the function. So let's plug in. We get -6, a -6, divided by 2 times -1. And so -6 would be 6 divided by -2, which is a -3 for our x value. So we can say the vertex is found at -3 something. Now let's plug that in, and we get y equaling a -3 squared minus 6 times -3 plus 3. So then y equals -9 plus 18 plus 3. So that gives us a y value of 9 plus 3, which is 12. And so -3, 12 is our value. So -3 and then 12 is way up here. So we have a y-intercept of 3. And so our vertex is going to look something very similar to that. And so now you can see that here we have a maximum because we're opening downward because our a is negative. And so we can say our axis of symmetry is x equals -3, because that is what this axis of symmetry will look like. And we have a max with a y value of our y value that's in our vertex, 12, because no values of y will be higher than 12. All right, let's look at another example. So we can identify a here as -2 and b here as 2. So then we get x equals -b divided by 2a. And so x equals -2 divided by 2 times 2. And so we get x equals 2 divided by 4, which x is 1/2. So we can say our vertex is 1/2 something. And so now we plug in that 1/2, and we get y equaling f of 1/2. And so y equals -2 times 1/2 squared plus 2 times 1/2 plus 1. So y equals -2 times 1/4 plus 1 plus 1. So y equals -2/4 plus 2. So y equals -1/2 plus 2, or we can change that to 4/2, and that will give us y equaling 3/2. So y equals 3/2 as our value. So our vertex is at 1/2, 1.5, so right there. And we can see that our y-intercept is at 1, so our graph looks something like that. And so we can also see that that's a max, and we have a axis of symmetry at x equals 1/2, and we have a max when y is at 3/2. All right, let's look at some other examples. All right, in these, we're going to just try and match our graphs. So besides using -b divided by 2a and f of -b divided by 2a to find our vertex, we can also find a vertex based on the change. So if you have y equals a x minus h squared plus k, we can also find the vertex by looking at h comma k. And so as you remember, with our inside we go the opposite of what you think, and k does exactly what you think. This will help you find your vertex. So we can look right here and say, okay, this vertex is at 4, -1. Here, this is x minus 0 squared minus 3. So we have a vertex at 0, -3. And this one has a vertex at -3, 4. And this one has a vertex at 4, 3. And here, because that's a negative, we know that that will generate a maximum. This one is positive, so this generates a minimum. That one generates a maximum. And this +2 generates a minimum. So 0, -3 is probably the easiest to find. So that's B. So this one's B. And since we found that one to be the minimum, the other minimum is at 4, -1. So we can see that right there. So this one's C. So let's look at number 2. That's at -3, 4. So this is -3, 4. So right there. So this is D. And our last answer choice is A. And you can see clearly that the vertex here is a maximum at 4, 3. And we had a max at 4, 3 in 4. So this one is A. That's all I have for you today. I hope you enjoyed matching these graphs. Happy studying.